Okay, and today we're going to take a look at the last section in Module 1. And it's actually I guess not a review, but it's more on equation writing. As far as, I guess, the homework problems is concerned, up to this point, we've kind of touched on all of the elements that are actually in 1.6. But for our test, which is on Sunday, right? And I'll talk more about the test in just 1 second. Okay, as far as the test is concerned, you will have to write out equations. All right, so kind of going through what we're going through once again won't necessarily be in vain. All right, so here we're going to revisit equation writing, and we're also going to take a look at how to graph using XYZ as well. Okay, and as far as equation writing is concerned, right, we're going to revisit the slope concept. Okay, remember that the slope is the rise over the run, right? You can physically count the rise, and the rise can go up or down, and you can count your run, right? Your run is to the left or to the right, right? We also talked about the nature of graphs or the classification of slopes, right? Here's the formula for the slope through 2 points: y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Right? And as far as slopes are concerned, okay, if your graph is increasing, so that means as you read your graph, and we read graphs from left to right as we read sentences from left to right. So if your graph is increasing or going up, it has a positive slope. Okay, as you read your graph from left to right, and if the graph descends or decreases, we have a negative slope. Right, and there were two types of special lines. There was a horizontal line, and it has a zero slope. And these equations are in the form y equal to some constant. And then we have vertical lines. And for vertical lines, they have an undefined slope. And these equations are in the form x equal to some constant. All right, so we're first going to start out with a simple example on finding the slope through 2 points. All right, so here we ask to find the slope through points 1, -1 and 3, 3. All right, so once again, I always like to write the formula that we're going to use. So we're finding the slope through 2 points. So our formula is y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So I'm going to label my points as x1, y1, x2, y2. Okay. And now I'm going to simply substitute. So y sub 2 is 3. There's a minus in my formula. Y sub 1 is a -1, so I must be mindful to substitute in a -1, divided by x sub 2, which is 3, minus, because there is a minus in our formula, x sub 1, which is 1. In the numerator, the double negative makes a positive, so we have 3 plus 1 over 3 minus 1, which gives us 4 over 2, which gives us a slope of 2. All right, and since this slope is positive, if we were to graph those 2 points, all right, and draw a line through those 2 points, that graph would increase as we read it from left to right. All right, so next up we have the slope. We're going to look at actually writing an equation. Okay, and I'm actually looking through the homework problems to find an example. Okay, so let's take a look at, okay, this is one that is similar to number 8 on module 1.6. So we're asked to write an equation parallel to the equation f of x is equal to negative 5x minus 3 and passes through the points 4 comma negative 21. All right, so whenever we're asked to write an equation, all right, keep in mind we are going to utilize the point slope form. Right, and the point slope form is y minus y sub 1 is equal to m times the quantity x minus x sub 1. Right, where m is your slope, x sub 1, y sub 1 is your point on the line. All right, so what is the slope? Well, we talked about parallel and perpendicular lines. So 2 lines are parallel if they have the same slope. 2 lines are perpendicular if the products of their slope is negative 1, or if one slope is the negative reciprocal of the other. So what's our slope in this case? Well, we're given this equation, f of x is equal to negative 5x minus 3. And our line has to be perpendicular, our line has to be parallel to this line. So let's determine the slope of this equation. Since this equation is in slope-intercept form, right, y equal mx plus b, since this is in function notation, we have replaced y with f of x, okay, but nonetheless, this is still slope-intercept form. The coefficient of x is our slope. So a line would be parallel to this line if it has the exact same slope. So the slope for our line should also be negative 5. So we're going to find, I'm going to actually put some sets here. The first thing we had to do was find the slope. Right, so if your equation is not already put in slope-intercept form, you must solve it for y, put it in intercept form, and then determine your slope. So we determine that the slope is negative 5. So the next thing we'll do is we'll write the equation. And we're going to use the slope, negative 5. And we're going to use a point on the line, 4 comma negative 21. So we're going to use point slope form. Right, so we have m is -5. We have x1 as 4. We have y sub 1 is -21. And now I'm going to substitute. So we never know x or y, but we should know everything else. So I'm going to bring down the y minus. I'm going to substitute y sub 1 as a -21. So we have to make sure we substitute in y sub 1 as a -21. That's equal to m, which is -5, times x minus x sub 1, which is 4. On the left-hand side, I'm going to simplify by rewriting this double negative as a positive. So we have y plus 21. I'm going to distribute on the right-hand side. So -5 times x is -5x. A negative times a negative is a positive. All right, and 5 times 4 is 20. All right, so our last step is to write it in slope-intercept form. So I'm going to subtract 21 from both sides. All right, so I believe once we subtract 21 from both sides, our final equation should be y is equal to -5x minus 1. All right, so y is equal to 5x minus 1 is parallel to the equation -5x minus 3, and it passes through 4 comma -21. All right, so we're going to take a look at another example. And I'm actually going to give you a second to do this before, okay, we actually look at the solution. So here we want to find an equation perpendicular to f of x is equal to -2x plus 4 and passes through -4 comma -6. All right, so at this time, I'll give you about 5 minutes or so. I would like for you to attempt to work the problem, and then we'll take a look at the solution together. Sorry about that. Okay, we're going to go ahead and take a look at the first part of the problem. And here we're asked to find an equation. So we know that we're going to utilize a point slope form, right? So in a point slope form, we need to know the slope and the point on the line. So our first thing to do is to find the slope for the line we're given, right? Which is negative 2x plus 4. But the slope of our line is perpendicular to the slope of the given line. So we talked about before, there's something called a negative reciprocal. So in order to find the slope of our line, we must find the negative reciprocal for the slope of negative 2. So over here, I'm just write the number in this column that we're starting with, which is negative 2. And over here, we're going to write out the negative reciprocal, right? So our number is a negative 2. The next thing I'm going to do is in order to take the negative reciprocal of a number, we must first off take the number and multiply by negative 1. Right, so I'm going to take our number, which is negative 2, and in order to find the negative of negative 2, I'm going to simply multiply the given slope by negative 1. So negative 2 now becomes positive 2. Now I'm going to take the negative number, right, which is actually negative 2, and I'm going to reciprocate. Right? So I have a positive 1/2. All right, so my slope is negative 2. The negative reciprocal of negative 2 is positive 1/2. So the slope I'm going to use is 1/2. So now we're going to write the equation using m is equal to 1/2 through negative 4 comma negative 6. Right, so before we proceed any further, are there any questions about 1/2 as being the slope?
Can you explain just a little bit more about how you got 1/2?
Okay, how I got 1/2. Okay, now in abstract terms, two lines are perpendicular if m sub 1, so this little subscript just means the slope of my first line, times m sub 2, that would be the slope of my second line. If I were to multiply these two things together, if I have a negative 1, then the two lines are perpendicular, right? So if I were to take negative 2, right, and that would be the slope of my first line, and if I were to multiply that by some number, it must equal to negative 1, right? So we have to figure out the magic number such that when we multiply it by 2, we get a negative 1, right? So what's the magic number? Well, the magic number is going to be that negative reciprocal. So if we were just to take our value, and if we were to multiply by a negative, and then flip it over, right? That is our negative reciprocal, and that's also the magic number. So if I were to substitute in this question mark for 1/2, -2 times 1/2 gives us -1. All right, so the slope or the negative reciprocal of -2 is actually +1/2. All right. Does that clear it up a little bit more, or does it make it more confusing?
It cleared it up a little bit more for me.
Okay, okay. Now here's something else you can do. And it's sort of along these same little lines here, but it involves like an equation. So just based on that little setup, instead of putting a question mark in, I'm actually going to put an X in. So our formula was m sub 1 times m sub 2 has to equal to -1. And we're given the slope of our first line is -2, right? We don't know the slope of our second line, right? So I'm going to substitute that with X, right? Because that's our unknown. Before I had it as a question mark, but here I'm putting it in as X. And we know when we multiply our two slopes, if those two slopes are perpendicular, that product must equal to a 1. So you could set up an equation such as this and solve it for, -1. Right? You could set up an equation like this and solve it for X. Right? So what I mean is -2, that's our slope. We don't know what our negative reciprocal is, or we don't know the magic number that will multiply, we get a -1, right? So I set it up in an equation, and now I can simply solve it for X. So the opposite of multiplying X by -2 is to divide by -2. So if I were to divide both sides by -2, and I get -1, well, the -2's will cancel on the left. On the right-hand side, the negative divided by a negative becomes a positive, so I would get 1/2. Okay, this is like a more mathematical way to do it versus this little negative reciprocal deal. Okay, so if it's easier to take the negative reciprocal, okay, just take whatever slope you're given, multiply it by a negative, and then just reciprocate that number. Okay, that would give you the desired slope. Or if you set it up as an equation, right, keep in mind that the product of those two slopes must equal to -1, right? So we can set up an equation to actually find the negative reciprocal as we did here. All right. All right, so we get 1/2 as the slope, and it should pass through the points -4, -6. So now we're going to write the equation. All right, so remember when we're asked to write equation, we're going to use the point slope form. So we have m is 1/2. We have x1 and y1. All right, we're given -4 and -6. And now we're going to carefully substitute, right? You can't neglect any operations or signs. All right, so we have, I'm going to bring down y minus, right? We never know y or x. So I'm going to bring down y minus. Y sub 1 is -6. So I must be mindful to substitute in the negative and 6. That's equal to 1/2 times the quantity x minus, right, because this minus is a part of our formula, x sub 1, which is -4. So I must substitute in x sub 1 as a -4. On the left-hand side, the double negative gives us a positive, so I'm going to change my sign. I'm also going to change my sign on the right-hand side, so I have 1/2 times the quantity x plus 4. I'm going to bring down y plus 6. On the right-hand side, I'm going to distribute. So 1/2 times x is 1/2 x. Half of 4 is 2. Next, we're going to put it in slope-intercept form by solving for y. Right, so we're going to subtract 6 from both sides. Therefore, our equation should be y is equal to 1/2 x minus 4. All right, so y equal to 1/2 x minus 4. And the equation -2x plus 4 are perpendicular. All right. All right, any questions about that example? Okay, in this example, we just actually determine if the two lines are parallel or perpendicular. Right, we're given 4y plus 5x is equal to 6. We're given -12y is equal to 15x plus 4. All right, so based on everything we talked about, I'm going to give you a couple of minutes to try it yourself before we look at the solution. All right, let's take a look at the solution. All right, now in order to determine if two lines are parallel or perpendicular, you need to know something about their slopes, right? If the slopes are exactly the same, those two lines are parallel. If you multiply the products of the slope and the product is a -1, those lines are perpendicular. In order to determine the slope given a function, you must solve for y. So we must solve each equation for y. Okay, so the first thing we're going to do is we're going to find the slope for 4y plus 5x is equal to 6. Right, so the first thing we're going to do is I'm going to subtract. Well, first thing is I'm going to locate y, right? And y is on the left-hand side. On the same side as y is contained, we also have another term, right? 5x. 5x doesn't have anything to do with the y term, so I'm going to move 5x, or I'm going to transpose 5x to the other side. So now I have 4y is equal to -5x plus 6. I want to solve for y, not for 4y. So now I'm going to divide everything by 4. Right, so once everything gets divided by 4, and once that happens on the left-hand side, the 4's will cancel, and we're left with y. That's equal to -5 x plus 3/2. So our slope is -5/4. The second thing we're going to do is find the slope for our second equation. -12y is equal to 15x plus 4. All right, so here again, we want to solve it for y. So I'm going to divide everything by -12. Right, and I'm going to simplify. So we have y is equal to -5/4 x minus a third. All right, just reducing those fractions. Okay, we can pull out the slope, right? That's the coefficient of x. If we compare the two slopes, we see that the two slopes are exactly the same, so these two lines are parallel. Only thing we're concerned about is the slope, okay? All right, any questions about this example? All right, and it's just a few more examples. And this will actually be the last like handwritten example, I believe. And the rest of these things, I do want to show you how to graph using XYZ. So here it asks to write the equation. We have the x-intercept is -5, 0. And the y-intercept is 0, -4. All right, so I'm going to give you a second to attempt this problem. And it's sort of different than the problems we've been working out. Okay, so I'm going to give you a minute to decide a path forward and to figure out the answer. And then in about 2 or 3 minutes or so, we'll take a look at the solution. All right, so let's take a look at the solution. So here again, we're asked to write an equation. All right, so we're going to look at the point slope form because we are given 2 points. Okay, this is labeled as the x-intercept, and that's okay. This is labeled as a y-intercept, and that's okay. But nonetheless, we're given 2 points. Right? So as in a previous example, the first thing we're going to do is find the slope. So we have x1, y1, x2, y2, and we have the formula. So we're going to substitute. So y sub 2 is -4 minus y sub 1, which is 0, divided by x sub 2, which is 0, minus x sub 1, which is a -5, all right, so you must be careful with your operations and your signs. All right, so in the numerator, we have a -4, and in the denominator, that double negative makes a positive. And we have our slope, -4/5. So now we're going to write the equation where we have m is equal to -4/5. And I have 2 points, right? I can use this point or I can use this point. But keep in mind when we talk about slope-intercept form, which is y is equal to mx plus b, in order to write the equation, you only need 2 pieces of information. You need the slope and you need the y-intercept. So notice here they had given us the y-intercept of -4. So if you realize that, we can sort of piece the 2 things together, and we can write this equation out as -4/5 x minus 4. right? Because we know the slope, we know the y-intercept. Well, let's just say you didn't quite catch that. And let's just say you use this point instead of this point. Now, in being that it's the same line and all of these points are on the line, we would get the exact same equation. Right? But for argument's sake, I'm just going to work this out kind of quick. So let's just say we have the slope, m is equal to -4/5. And we're going to use this point on line, x1, y1. So we write out the point slope form. Y minus y1 is equal to m times x minus x1. So we have y minus y sub 1, which is 0. That's equal to m, which is -4/5 times a quantity x minus x sub 1, which is -5. So we have x minus, so this is where you have to be careful. There's a minus in our formula. And we have x sub 1 as a -5, so we must be careful to substitute in x sub 1 as a -5. All right, so on the left-hand side, y minus 0 is y. On the right-hand side, I'm going to distribute. Well, first I'm going to change the signs. I'm sorry. I have a double negative, so I'm going to just rewrite that as positive. So that's -4/5 times x plus 5. Now we're going to distribute. So y is equal to -4/5 times x is -4/5 x. When you multiply a negative times a positive, you get a negative. When you multiply 4/5 times 5, the 5s are going to cancel to leave 4. All right, so nonetheless, we get the exact same equation. All right, so now as far as the test is concerned, once you find the slope, and if you're given a y-intercept point, you can save yourself some time by simply substituting in the slope and the y-intercept into the point slope form. Right, so no matter what points they give you, they can label, have these special labels or whatnot. There are still 2 points that you can find the slope, and then you can put in the slope intercept form, or put in point slope form to write out the equation. All right, so any questions about any of the previous examples? So normally this equation writing part is the most involved because there's so many formulas and you got to be careful on how you substitute things in. All right, now for the last part, I'm actually going to pull up XYZ homework. All right, and we're going to take a look at some of the graphs that are down here. Okay, most of the problems that we did today, well, all of the problems that we have done today, they are similar to problems in this last module. I want to take a look at number 10, 12, 13, and 14. All right, for problem number 10, we're asked to find the slope. All right, so we know that the slope is the rise over the run. We can draw an imaginary triangle, right? Okay, I thought someone had a question. All right, so we're going to calculate the slope. So you may say, well, there's a lot of points on this line. So how do I know which points to actually take on the line, right? Well, the points you take on the line really doesn't matter. What does matter is you want to make sure whatever point you use, you're clearly able to pull out the coordinates, right? That means it kind of falls on one of our intersections on our grid, right? So I can actually pull out a point. So now the points you choose may be different from the points I choose, which may be different from the point your classmate chooses, but nonetheless, your slope should be exactly the same. So I'm going to just pick any 2 points on this line that I can determine its ordered pair point. So I'm going to take this point, right, because I can clearly see that the coordinates for this point are -5, -2. And I'm going to take another point. I can take this point, right? I can take this point. I can take any of these points that actually fall in our coordinate system. So I'm going to take this point and I'm going to take this point. Right, I know the coordinates for this point are -5, -2. The coordinates for this point are -4, -1. I'm going to sketch out my imaginary right triangle. Now, based upon what we know about the classification of slopes, as we read this line from left to right, it increases. So I know that my slope should be a positive number, right? So I'm going to draw my imaginary right triangle here. Okay, I'm going to start here and I'm going to count the distance between the point on my line and this imaginary vertex. So therefore, my run would be 1. And then I'm going to count the distance from this imaginary vertex to this point on the line. And again, I get 1. So my rise is 1 and my run is 1. So if I put my rise over my run, the slope here should be a positive 1. All right, so normally this problem is a little bit confusing because it's hard to determine which points to take. You just want to make sure you take points that you can clearly pull out the ordered pair points. So let's just say I were to take this point here, right? And if I were to take this point up here, I could draw an imaginary right triangle. And I can physically count my rise and run. Right? So I'm actually going to start here. And I want to count the distance between here and here. Right? So this would be my rise. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right? So my rise would be 11. And now I'm going to count the distance from here to here. Right? So that distance is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, my run is 11, my rise is 11. So if I put 11 over 11, I get 1. All right, so the thing here is just make sure that your ordered pair of points, you're able to pull them out. All right, we're going to take a look at number 12. And here we're asked to sketch a line with the given features. It has a y-intercept of 0, 5, and it has a slope of -2/5. So how we plot something like this on a number line is I'm basically going to use the point slope form, but not in the sense of writing an equation. I'm going to actually plot the point that I'm given. So it doesn't necessarily have to be a y-intercept. Okay, it could be any point on the line. But I'm going to plot the point that I'm given, and from the point that I'm given, I'm going to calculate the slope. So now just a few things about this. So notice that I'm given a point on the line, which happens to be the y-intercept. I'm also given a slope of -2/5. Now, based upon what we talked about on the classification of slopes, if our slope is negative, it's going to decrease or fall as we read it from left to right. All right, so we're going to keep that in mind. So I'm going to hit the draw icon, and I'm going to plot the point given first. I'm given 0, 5. So to plot points, we always start at the origin. The first coordinate is the left or the right movement. So our x coordinate is 0. So I'm not actually going to move to the left, and I'm not going to move to the right. My y coordinate is +5. So I'm going to go up 5. 1, 2, 3, 4, 5. And that is our point on the line. Right, from this point, we want to calculate or draw out the slope. So notice that our slope is -2/5. Oops. I'm going to go back to the camera for just 1 second. So the slope is -2/5. Now you have to make sure when you're, I guess, drawing out your slope, either the numerator has to be negative or the denominator has to be negative, right? So I can, what I'm trying to allude to is I can rewrite out -2/5 as -2/5, right? Because a negative divided by a positive is a negative. Or I can write it out as 2/-5, right? A positive divided by a negative is a negative. So really, no matter which setup you use, I'm going to use this setup. So remember, the top is the rise and the denominator is the run. So remember that a rise can go up and a rise can go down. So here I'm going to go down 2 units, and I want to move 5 units to the right. All right, so going back to the application screen. All right, so notice I plotted my point 0, 5. So for my slope, it's a -2/5. So from my y-intercept point, I'm going to go down 2 units, 1, 2, right? That's my rise. I'm going to run 5 units to the right. 1, 2, 3. 1, 2, 3, 3, 4, 5. So from our y-intercept 0, 5, we plot the slope. So I went down 2, and I went 5 spaces to the right. Okay, and we have our graph. All right, we're also going to take a look at number 13. All right, and here again, we're asked to graph. All right, so we have sketched the graph of the function below. F of x is equal to -4x + 2. So keep in mind that this is in slope-intercept form, right? F of x is equal to negative 4x plus 2. In order to graph an equation that is in slope-intercept form, there are basically 3 steps. To graph using slope-intercept form, first thing we have to do is put the equation in slope-intercept form. Which is y is equal to mx plus b. Okay, you have to solve your equation for y if it's not already done so. And this is by far the easiest way to graph because there's no table method, there's no points to figure out. It's simply making sure that your equation is in slope-intercept form. Right, m is the slope, b is the y-intercept. The second thing you do is you plot the y-intercept The third thing you do is from the y-intercept, you plot the slope. And then the last thing you do is connect the 2 points. All right. So just 4 steps. We put it in slope-intercept form. We plot the y-intercept. From the y-intercept, we plot the slope. And then we connect the points for our graph. So to take a look at that in action, all right, we have f of x is equal to negative 4x plus 2. So the first step is already satisfied. Our equation is in slope-intercept form. The next thing I want to do is plot the y-intercept. Right, so the y-intercept is positive 2. Okay, so I'm simply going to find positive 2 on the y-axis, and I'm going to plot that point. However, before I do that, there are some draw options. The first option is used to draw a straight line, a linear equation. The second option is used to draw a parabola or to graph quadratic equations. The next icon is to graph absolute value equations. Those are V-shaped equations, and we'll go through these in a later module. We can use the next icon to graph a circle, and the last icon is to graph a point. So here we're graphing a line, so I'm going to choose the line icon. I'm going to plot the y-intercept, which is positive 2. So I'm going to find positive 2 on the y-axis, and I'm going to plot that point. From the y-intercept, I'm going to plot the slope. So now, as far as the slope is concerned, the slope would need to be written out in a fraction because we need a rise and a run. Therefore, we're going to rewrite negative 4 as a fraction, and we're going to write it out as negative 4 over 1. So if I were to plot the slope from the y-intercept, I'm going to go down 4 units. 1, 2, 3, 4. I'm going to run 1 unit to the right. So notice as I read my graph from left to right, the line decreases or goes down. That's just an indication of if my line has the right orientation. All right, so this is the graph for number 13. All right, so are there any questions about module 1.6? All right, any questions about module 1.6? All right, now just some things about our test. I'm going to go back to the application, the desktop shared screen for just a second. And as far as our test is concerned, okay, and this kind of caused some problems in one of my other classes. When you are attempting to take the test, please don't access the test from XYZ. If you access the test from XYZ, this is what's going to happen. You will be prompted for a password. Okay. The honor lock proctors have the password. So in order to properly take any of the tests, you want to visit your Blackboard homepage. So this is our 110 section 2. You want to visit the honor lock link. You want to click on test. You want to find the appropriate test. Okay, so once September the 4th comes, this will open it up. I think I'll actually open this up today. All right, you'll take the appropriate test. So once you click on the module 1 test, you'll be redirected to HonorLock. I believe they're going to ask for a scan of your room, so you're going to need a webcam. You'll need a picture ID, so they just need to verify that you are the person you say are taking the test. And you will be allowed to use a sheet of notes, right, front and back. You'll be able to use a handheld calculator, okay, but no cell phone calculator emulators whatsoever. You're able to use scratch paper and some writing materials. All right, and the test is also timed at 120 minutes, which is 2 hours. Okay, someone had a question. Okay, how many questions are on the test? Let's see, there are let's see, module 2, module 1 test. Okay, that's actually a good question because I didn't make up any of the tests. It seems like there are it says total possible points 64. Oh, there are 32 32 questions on the module 1 test. All right, any other questions about any other questions about anything? So there's actually 32 questions on the test, and I believe there are 32 questions on the quiz. The quiz and the test are similar. They're not exactly the same, they're similar. So when you're making your notes for the test, I would recommend that you take the quiz before you take the test, and you should make the majority of your notes based on the quiz. All right, so are there any other questions? All right, if there's no further questions, see you all next week. And I'll put a test reminder up, possibly Friday, just kind of reminding everyone on the test date. And just again, I'll put a short video up just explaining how you actually take the test through that honor log link. All right. Well, no further questions. You all have a good afternoon and a good weekend.